Okay, this is Don Quimby, and I want to get into the atomic structure and probably just get to the nucleus today. Um, with an atom, we have electrons out here, and in the nucleus you have positives, and the positives and the negatives, those electrons out there, remember, are negative. The positives and negatives track, so these electrons kind of go around in an orbit, so to speak. Here's the nucleus here. I've just shown positives there. Here's the nucleus. And the question is, what holds the nucleus together? Now, electrons are negative. Protons are positive. Positive and negative attract each other. The positives in the nucleus hold the electrons in orbit around the nucleus. Neutrons are neutral. No electronic attraction or repulsion. We'll talk about those a little bit. Back to this one. Here we have all these protons, and yeah, they're going to just fly apart, except for one thing. One thing's holding them, and that is when they're close enough, they have strong nuclear force for each other. Very strong nuclear force. Strong nuclear force. Usually they just say strong force. And that's an attraction. A very strong attraction. And if you can break that, if these get far enough apart, this thing would probably go flying off. Of course, it's got a strong attraction here also. But if you can break that bond right there, that strong nuclear force, that means getting these kind of far apart. Because when they're close together, that's when you have strong nuclear force. Sort of like magnets. When they're close together, they pull together real tight. When they're far apart, gravity can pull them down or whatever. You know what I'm talking about. So, strong nuclear force only when they're close. Except for one thing. These also, though, for instance, that one there, let me put it in red. That one is being pushed away by this one, this one, this one, all of these pushing it away. Now that strong nuclear force that it has is only from the close ones. These have strong nuclear force on it, but it's very weak way out here. The electronic repulsion, electrostatic repulsion, pushes that away about the same from here to here as from here to here. As from here to here. These are pushing it away with electrostatic repulsion, but the strong nuclear force on these right here is greater, a lot greater. Okay, but if you have so many out here that are pushing it away, maybe it will leave. Well, there's got to be something else in there, and there is. They're called neutrons. N. If you put these N's in here, N, I put an N right there, that's going to have a strong nuclear force with this proton right here. And that'll help hold on to it. So we have these N, 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 N. And these N over here, they don't hold on to it very much. I mean, tiny, tiny, tiny bit of, magnetism sort of idea. Because they're so far away. Only the neutrons that are up close hold it tight. And if you have enough neutrons here, then it's going to hold it together. Now, what about these over here? These are also, this would want to fly off, right? Because protons over here pushing away. But with the neutrons, that's going to help hold that there. This proton will actually help a little bit. This proton a little bit. These protons over here, not helping that one very much. So the same idea on the other side. That's all I'm saying there. Now, if you get big enough of an atom, like uranium, 92 protons, plutonium. What's the other one there? Neptunium, I guess it is 93. Plutonium is 94. Okay. So if you get big enough, there's going to be so much push out here from all these protons, so many of them, that the strong nuclear force of these close neutrons and close protons is just not going to do it. And that thing's going to fly off. And with enormous, it's going to get thrown away from all this push here with enormous energy. And the energy from just 0.7 grams of material is all it took for the Hiroshima bomb to just blow up the whole city. The whole thing. The weight of a butterfly, all the energy within a butterfly, 0.7 grams, is produced all that Hiroshima bomb energy. Just amazing amount of energy from nuclear power is just amazing. Okay, so if you have any questions, talk to me in the comments, and I'll try to answer them as soon as I can. So right now, I think I can end this video. I'm looking here to see if there's anything else. Do like it if you can, subscribe, and I'll try to get some more of these up. And by the way, yeah, maybe you would like to see my face on here. I don't know why. I've recently had some dental work, and so maybe I can. But like right now, I can't talk that well, and because of the dental work, and I don't look that great. So, alrighty, have a good day. Bye.